Hello everyone, welcome back to MAT052. Today we're just going to go through a Chapter 7 review and then a Chapter 8 review for later on. But this week is basically Chapter 7 and Chapter 8 to get you ready for next week, upcoming test week or the week after. Okay, so let's kind of go back over. We'll start back with Chapter 7 and then we're going to put everything together and actually work a couple of problems for this. And I'm going to get you to submit those same problems later on for attendance / grading, and it'll get you to work back through those problems. But go ahead and just watch me first. Try to redo the problems yourself. And what I'm going to be looking for is all of the elements that we're going to be talking about when we know the pictures, the critical values, and all of those things. Okay, so let's get with a general review. Get going. Okay, from here, let's go through our slideshow. So the confidence intervals, this is what confidence intervals were all about. Let me shrink me just a little bit. How do we estimate a population parameter? So we don't know anything about the population, maybe other than it used to be a certain value. So there's going to be an idea that maybe we know what the population standard deviation is. But in general, we want to know something about the population. We don't know what it is. It's too big to go out there and just start measuring the data items and get everything for the population. Okay, so what we were going to do is basically go take a sample and look at the sample statistic. We'll use the sample statistic as our first estimate of what's going on in the population, and that's from the sample. So this first estimate we call the point estimate when we're doing confidence intervals. It provides the center of an interval. So what we return when we do this confidence interval calculations is some range of numbers that the population parameter could be in. And what we're going to start with was the sample, and then that's going to be the center, and then we'll use the margin of error formula depending on what we're trying to estimate to go with. Okay. So the point estimate provides the center of the interval, a range of numbers where the population parameter would likely be contained in. We then build the range of values by utilizing the parameter's margin of error formula. Each parameter has its own margin of error. This is like a cookbook. You just can't you're going to do a plain white cake and then you go, well, this is all I know is my chocolate cookie recipe, and throw everything in there. You've got to go to your recipe book. I'm talking about a white cake. Find me the white cake recipe. Okay? And that's what you follow. Okay. So here's the confidence interval. Here's the general confidence interval formula. I've got it for the mean up here. It all depends on the population parameter that we're trying to estimate and build a confidence interval for. Right now I'm talking about here's for the mean. So the mean lives, I've got a question mark here because that mean, once we build this interval, it could be anywhere in there. Between the point estimate minus this margin of error, where we calculate the point estimate plus the margin of error. And what's the point estimate? This is going to be like X bar for the mean. Okay. So it all depends on some of the other things that we have. Well, we've got two recipes for white cake. One requires us to use, let's say, cream, but we don't have any cream. The other one is just milk. We have milk. We've got to use the one that we've got. Okay. So here's the mean, point estimate. The population mean is going to live in here. The point estimate for the population for the interval mean where sigma is known, X bar, and then your margin of error formula. This is what I told you that you've got to go through and make sure that it matches whatever the information. Here is Z alpha over 2. We'll talk about that as we go. The sigma divided by the square root of n. N is your sample size. The population standard deviation. If you don't have it, you just can't plug the sample standard deviation and make it work. You've got to change everything that you've got. I can get the Z alpha over 2. I've got to have this, and I've got to have the sample size. If I don't know sigma, so I just switch the size for us, everything's the same. My point estimate is still X bar. But here I only know S from the sample. I calculate the mean, I calculate the standard deviation, I do my 1 bar statistics, And here it says you must use T alpha over 2. So we've got to go to table A.3 and then work on this as we go, and we'll talk about it more. So there, what about for proportions? Again, everything depends on what we're doing. Now we're talking about chocolate chips, right? The proportion, here's the P, it's going to, this is the population. It is in here someplace, but I've got its own margin of error, so we're going to take that point estimate. The point estimate is going to be P hat, the sample proportion, add the margin of error, subtract the margin of error, and that's what our confidence interval will look like for proportions. Here's the P hat, our point estimate is P hat, and then our margin of error formula, again, everything depends on. Here's our P hat, and we're able to go and use Z alpha over 2 for that one as well. The data table A.2 in the back of the book. So for Z alpha over 2, I'm going to go to table A.2 for the normal distribution. I'm going to do my alpha is 1 minus C. So if I'm building it at 95% confidence interval, then I'm going to do 1 minus 0.95. That would be the 0.05. That matches. This is telling you to do the alpha. Once I get 0.05, I divide it by 2, and I'm looking for Z of 0.025 for that case. Okay. We'll work through that in just a minute. A.3, if it says to do T alpha over 2 in our margin of error formula, we still do our A, 1 minus C, divide alpha by alpha over 2, but that T is also going to do our degrees of freedom, which is the N minus 1. It requires that when we work through it. Critical values for C, so here's the critical values. We go through and we say, this one table kind of fixes it up for us. 90%, that would be a alpha 0.10. The Z alpha over 2 would be the 0.05. And if I went and found 0.05 area in table A.2, I would see a 1.645 for the Z score in there. It would actually say negative 1.645 because I'm doing the left tail type thing, but it's symmetric on both sides. It's going to be plus and minus 1.645 depending on which side. Okay, so here's a quick way that you can do, but if you have to go in through any strange ones at 85, you know, something in between, then you're going to have to go through and work that out. The standard error is the part of the margin of error without the critical value. Okay, so there's always two parts. There's some critical value, which is the Z alpha over 2, T alpha over 2, and then the rest of this piece, that's the standard error. That's kind of the standard deviations of the samples. Okay, it's sampling statistics. When we went through and we said, well, if we do a sample, the mean of the means, the standard deviation, and then that's kind of what this is. So it's the standard error. So let's look at an example. Let me kind of go out of, I'm going to do a couple of different things here. I'm going to switch out, and I'm going to go and I'm going to use a little whiteboard to work on this. So an owner of a fleet of taxis wanted to estimate the mean gas mileage in miles per gallon of the cars in the fleet. A random sample of 40 cars is followed for 1 month, and the sample mean gas mileage is 23.2 with a standard deviation of 5.8. Construct a 90% confidence interval for the mean. Okay. So what I'm going to do is I'm going to use a little whiteboard here, and hopefully I can get everything down for you. I've got to do a couple of switches. I'm going to bring this down, and then here up. And then hopefully I can do some little whiteboard stuff. This is backwards. So let me switch, and now I'm right, and I'm going to expand this thing for us. Okay, let me get it up here, get it started. And I think we can work on this from here. Okay. So an owner of a fleet of taxis wants to estimate the mean gas mileage in miles per gallon of the cars in the fleet. A random sample of 40 cars is followed for 1 month. So let's go ahead and write over here what we've got to start with. So I've got an N is 40. That's my sample size. The sample mean gas mileage, the sample mean, well, that would be the X bar, and that's the 23.2. And then a standard deviation. Now it says, and the sample mean gas mileage with a standard deviation. That's all in that sentence over here. If I go back over here, a random sample of 40 cars, all of that. So all of this is based on the sample, and then I have my sample standard deviation of 23.2. So that gives us all the information we need, and we just have to go back and recall that what are we doing? We're building a confidence interval. Here's our point estimate, and that's going to be our X bar. That's our 23.2 in the center. So I'm going to add over here a margin of error, and then I'm going to subtract the margin of error from the 23.2 to give us that interval, the two numbers. So our next step is we've got to do a margin of error. So what was the margin of error formula? I don't know sigma in this case. So my formula is going to be the T alpha over 2 S over the square root of N, and there's our T alpha over 2. So we want to build 90% confidence interval. So I basically got, here's my standard kind of bell-shaped curve for building confidence intervals. It's always a two-tail type thing. We've kind of touched on what 8 is with two tails, but both of these have got a little area in there. Here's our 0.90 area inside. That's the 90%. That's from there. And then how much is outside? Well, 10%, right? Everything's 100%. And then, so if I subtract the 90%, I get 10% outside, but it's divided between the two tails. So my alpha over 2 is, this is 0.10, and my alpha over 2 is the 0.10 divided by 2, which is the 0.05. So each one of these has 0.05. So let's do, so I've got to find this critical value here, and it says that I need to use T alpha over 2, and this is just going to be minus T alpha over 2. Okay, so let's go back up here. I'm going to assume that you know how to go grab the critical values for T's, and what I'm going to do is calculate it real quick. Now let me do that real quick. Calculate, menu, let me go into my calculator. I want to grab it from my calculator. Distributions. My inverse T. So my inverse T is going to be based on 0.05. My degrees of freedom for this thing, my degrees of freedom is my N minus 1, which is just my 39. So if we were going into the table, I'd go down for 39, and then look at the area at the top, 0.05. 0.05 to the right is what they're looking for, and that would give me a 1.68. So this thing is my CV. Let me go back over here and write my CV is 1.685. This is T alpha over 2. Okay. So now all we have to do, let me kind of switch this thing down just a little bit if I can get it up here. And now all I've got to do is my margin of error, which is, this is from our S over the square root of N, T alpha over 2. So that's the 1.685 times my S, which is 23.2. over the square root of 40. So I'm going to go back to my calculator. And that should be 6.18, 6.181 to 3 decimal places. And then I'm just going to do X bar. Oh, I got to get up some. So I'm going to erase this a little bit and move this up here. I'm going to take out the middle piece. So my X bar is going to be, my upper range, my upper boundary is X bar plus the margin of error, and that's just the 23.2 plus the 6.181. So 29.381. And the lower boundary is the 23.2 minus that 6.181. And I'm just going to go up here and recopy this and just change my sign. And 17.019. Okay, so if I'm going to write it as an interval, I would do 17.019, comma 29.381. That's just the interval piece of it. And then if I want to write it as my inequality, 17.019 is less than, what are we looking for? This was for the mean. Confidence interval for the mean, less than 29.381. And we would just finish it up. Okay. We can say with 90% confidence that the true mean of the mileage is between 17.019 and 29.381. So that would be how we did a confidence interval with everything in there, all the basics of it. You know, calculate the margin of error, T alpha over 2, and then doing the lower boundaries and the upper boundaries. Okay. So let's move on. The amount of time that a certain cell phone will keep its charge is known to be normally distributed with standard deviation sigma is equal to 16 hours. A sample of 40 cell phones had a mean time of 141 hours. Let the mu represent the population mean time that a cell phone will keep a charge. What is the point estimate of mu? So let's start over here. Go back down, get it all squared out. I know you're seasick. So what is the point estimate of mu for A? The point estimate for mu, that's X bar again. We're still there. What is the standard error of the point estimate? We're just going to write down the formula. That's going to be the standard error is just S over the square root of N. Remember the margin of error, we're going to have to build that in as well. Okay. So our X bar, what is our X bar? The amount of time a sample of 40 cell phones had a mean time of 141. That's from the sample. The N was 40. Okay. The standard error, let's see, hold on, sigma. So here we're given sigma. I need to change this because we're given sigma in this case, and that had a sigma of 16 hours. Okay. So the standard error, which is sigma over the square root of n, 16 divided by the square root of 40. And I'm going to go ahead and write that out. (16) divided by the square root of 40. And a 2.5298. Let's go with 2.5298. 2.5298. That looks like mainly the most significant digits in here. Okay. And then excuse me, dogs. Suppose that a 95% confidence interval is to be constructed for the mean time. What is the critical value? So again, I've got to draw my little curve. For confidence intervals, we're always doing this on the inside. I need to do a 95% confidence interval. The only time I'm going to do that right at this point is once I get this. So the area on the inside is 0.95. The area on the outside is 1 minus the 0.95, which is 0.05. And this is in each tail, so I've got to go 0.05 over 2. 0.05 over 2. Which is 0.025, and this is 0.025. So now I need these critical values. I have to go and do my margin of error because that's going to tell me whether I need to go to the t, is that a t alpha over 2 or z alpha over 2, and that the margin of error for confidence intervals with sigma known, that's going to be z alpha over 2. Times sigma over the square root of n, and this was just the standard error that we previously calculated. So the z alpha over 2, z per 0.025. And I'm going to run back up here real quick, and let's see if we can find that in the table. For 95% confidence, that's the 1.96. And times the 2.5298. And then if I do that on my calculator, and that's just 4.958. And now I just need to do for my upper boundary, that's my x bar plus my ME, 141 plus 4.958. And then my lower boundary is x bar minus ME, 141 minus 4.958. That value is 155, 145, 0.958. And then my lower and that's going to be 136.042. So there's my 2, and then we just have to finish it up with a statement. So let me kind of open this up a little bit so I can use the bottom. And then, so my final statement would be something like, with 95% confidence, we can say that the true mean is between 145.958 and 136.042. And I usually like to write this with the smaller and then the backwards, but I just kind of went with that. Okay. So that's our confidence intervals for a mean when I know what sigma is. Okay. So once I know that, that tells me which margin of error formula I should know. Okay, so let's do one more. Put this down here. Let's erase what we have. Hopefully you've got everything. In a survey of 802 U.S. adult drivers, 265 state that traffic is getting worse in their community. Construct a 99% confidence interval for the proportion of adult drivers who think the traffic is getting worse. Okay. So a proportion, they've talked about the proportion in there. So what we're going to do is a CI for P, the population proportion. I've got X is 265 and N in my survey was 802. So I've got to calculate P hat from those, the sample proportion. So this is just going to be my 265 over 802. So my P hat that's going to be 0.3304, 0.3304, and we can just call it 0.33, but I want to keep as many digits as I can, so we'll go with that. Okay. So again, this is exactly what I'm doing here. I've got doing a 99% confidence interval. So 0.99 is here. Outside is the 1 minus 0.99. So alpha is 0.01. And I need half of that in each one of those areas. So 0.005, 0.005. That's 0.01 over 2. Okay, so if we went to the tables, we would do that. Then we do the critical values. Which one do we need, Z or T? The margin of error formula is going to tell us. We're doing it for proportion. So it's Z alpha over 2, P hat 1 minus P hat all over N. So I'm going to go back again for the 99%. I'm just going to use that quick table that we got up here. And if I can slide this down, the 99%, this CV is 2.576. Up here, 99%, up there, that gives it to us directly. And then I've just got to do the calculation here. So let me go back up. From here, maybe open this up for you. So my P hat is 0.3304, 0.3304. 1 minus 0.3304. All over 40, no, sorry, all over 802. And I got to do all of this first before I take the square root in there. So if I do that, my margin of error, if I'm going to run my calculator, .3304 times 1 minus 0.3304 divided by 802 . if everything went in right, 0.0428. And this was more like 7/8, so I just rounded that up to there. And then all I got to do now is my upper boundary. That's my point estimate, and the point estimate was just p hat 0.3304 plus 0.0428 0.3732, and my lower boundary is just this minus that. At 0.2876. And that gives it to us. So now we can just finish this up. So here, let me write this one right here as well. So this is 0.2876 is less than P, the population proportion, not P hat. We know what P hat is. And then 0.3732. So P lies somewhere in there. And then we just finish it up with our general statement with 99% confidence. We can state that the true proportion, and naturally we would like to put some context in there from the statement, lies between 0.2876 and 0.3732. Okay. So that basically kind of finishes that up for this section for our review. That kind of went through each one of the confidence intervals that we had to deal with. T-scores, Z-score for the confidence critical values, and then one we knew what sigma was, the population standard deviation, and then one we were only given that the sample standard deviation. So take a look at these. These problems are in the Word document. Go through that worksheet. Make sure you kind of work through these things, can do them on your own, and submit those. Okay, and have a good day. We'll see you next time.